So we came up with 6 different ones, and now we're going to look for a pattern. Besides the fact that they all equal 17 pi over 12, what do each of the colored ones have in common? They each have a pi. What else? And this pattern, if you see it, is going to help you figure out any pi over 12 at any time.
They're added or subtraction on the family directly next to it.
Right. They're all added and subtracted. That's our idea. We needed to add and subtract too.
Directly next to them. Like 3 directly next to 4.
Oh, we do 3 and 4, or 6 and 4. We never did 3 and 6. In other words, you're very close to the main pattern here. What is always in each one of them? There's always an odd and an even one, yes. But there's something in each one of them that happens every single time. Oh my, I don't even turn the video on if I didn't put the mic on. Here we go. You basically said it in 2 ways that's more complicated than the actual way of saying it.
It's always from the 45 degree family, or like the pi over 4.
We always have a pi over 4 family. So by saying 1 even, 1 odd, that obviously has to have the pi over 4 as the only even one. By saying 2 next to each other, you always had to include the pi over 4 one. Right? So just saying pi over 4 makes it easier. In fact, can someone tell me from the pi plate a pi over 4 we did not use? Can someone tell me 1 pi over 4 we didn't use? Did we use 7 pi over 4? So you can find any pi over 12 by starting with any pi over 4 that you like. If I started with 7 pi over 4, if I multiply that by 3, can you see that that's 21 pi over 12? That's too much. What would I have to do to get back to 17? I would have to subtract 4 pi over 12. If you start with the pi over 4, whatever you do to make it work, if I reduce this, sure enough, it's another one. So I started with 25 pi over 4, just randomly. And then I figured out I would need to subtract 58 pi over 12 to make it work, and when I reduced it, it was a pi over 6 family. Now, of all of these ones, I would not recommend the red one, because you really have to deal with coterminal angles. But anything that uses the first time around your circle is really nice. I find that students tend to really like the blue one or the black one. Some students just like, I'm going to just start with a basic pi over 4. Basic pi over 4 is 3 pi over 12. What would I have to add to get to 17? I'd have to add 14. You see that 14 reduces to 7 pi over 6. And it's super easy. And one of the things that I kind of hinted, it's only the pi over 4 that gives you an odd number when you change it to pi over 12. And if you need to add 2 things to another odd number, one of them has to be odd. So you always have to use the pi over 4 family. That makes the start of these questions, which is supposed to be the hardest part, really easy. So if I want to find cos of 17 pi over 12, I start with any pi over 4 family I like. Sometimes I even write them out, like this one's 3 pi over 12, this one's 9 pi over 12, this one's 15 pi over 12, this one's 21 pi over 12. Some people like to choose the one that's closest to 17. Most people don't like subtracting, so they don't like to go over, but it's not wrong, because you can use adding or subtracting. So of course, I go over and subtract. But any of them would have worked. Then, after and I like to write it out with the 12s, then I like to reduce it to find out what's on my pie plate. And the first one's your alpha, and the second one is your beta. Yes. Then you go to your cos alpha plus beta, alpha minus beta formula. Since we're subtracting, I'm going to use the cos alpha minus beta formula, which is cos alpha, cos beta plus sine alpha, sine beta. And now that all of these are on your pie plate, it's just cos of 7 pi over 4, cos of pi over 3, plus sine of 7 pi over 4, sine of pi over 3. And this is where it's nice that you get to use your official pie plate for this next test in chapter 7. So for questions like this, you can double check that you've got them right. But maybe by now you've got them so well memorized, it's like, oh, I knew that. I would still say, even though you can use your pie plate, try to do it first in your head, and then you just use your pie plate to confirm that you've got it right. Yes?
So you said that's for our test that we get to do that?
For your chapter 7 test, you get to use your pie plate. And then when you get back to your exam, then you have to do it from memory again. Technically, you can use your pie plate on other unit tests, but I don't ask any questions that you did. So it's... Now when you multiply fractions, multiply tops, multiply bottoms, you see you're going to already have a common denominator of 4. Your final answer has to be a single fraction. And so you get a root 2 minus root 6 over 4. This is our third pi over 12 question we've done in our notes. Did you notice the answer in the first pi over 12, the second pi over 12, and the third pi over 12? That all of them have a root 2. All of them have a root 6, and all of them are over 4. This will always happen. But what's going to happen that, like, sometimes everything's positive. Sometimes, like this, one is positive, one is negative. Sometimes they're both negative. That's the only thing that's going to change. And that's for sine and cosine. Tangent just has a bunch of root 3's in it, if you do a tangent pi over 12 question. Okay? If you get a secant pi over 12 question, all you would have to do is take your cos answer and flip it. Okay? In about, I'm going to say, around 2008, provincial exam around 2008, had a question like this: find the exact value of secant of 7 pi over 12. The strategy would be, first find cos of 7 pi over 12, get your answer, and then whatever your answer is, just flip it. Okay? Unfortunately, in 2008, too many students didn't write anything down because they were like, I only know how to do cos and sine of pi over 12. I don't know secant. I'm stuck. And they left it completely blank. Got 0 out of 4 marks. So people writing the exam felt bad for them. And so the trend after 2008 was, if we want to ask secant 7 pi over 12, we always make it part 2 of a question. Part 1 is worth 3 marks, which was cos of 7 pi over 12. And then part 2 is worth 1 mark, which asks you secant of 17 pi over 12. And if you had no clue on the exam, you forgot how to do pi over 12 questions. So you just made up that the answer was 3/5, which is completely wrong. You get 0 to 3 on part 1. But then in part 2, you wrote down 5/3. They gave you 1 out of 1. Because all you have to know for secant is that the ratio gets flipped. So you knew the right idea with the wrong numbers. The exam is nice that way. If you have the right idea with the wrong numbers, and that's worth a point, they give you that point. The answer is not 5/3. Don't write that in your notes. There we go. Whew. Yes, here we go. And here is an exam question that also lots of students left blank. What makes this one harder than normal? They put a 4 out in front. Students were like, well, if that 4 wasn't there, wouldn't this be just a cos pi over 12 question? So do just cos of 11 pi over 12. Whatever answer you get, what are you going to do? Multiply by 4 at the end. So let's do cos of 11 pi over 12. I picked pi over 4. And then I'm like, well, what would I have to add to 3 to get 11? I'd have to add 8. When I reduce those, sure enough, they're both on my pi plate. So this strategy of starting with any pi over 4 you like will always work. So another reason people like this unit, pi over 12 questions are very predictable. Proofs, a little less predictable, but you have your strategies, and if you get good at your strategies, the proofs also very nice. Guess we'll find out on Monday how well the proofs are going. Then this is cos alpha, cos beta minus sine alpha, sine beta. Use your cos alpha plus beta formula. Get the values from your pi plate. And of course, you have a root 2, a root 6, then it's all over 4. This time they just all happen to be negative. So then, what would 4 times that equal? Well, you just multiply both sides by 4, and you just get negative root 2 minus root 6. Yes?
Could you go back to the question?
I could go back here, I'll zoom out so we can see everything.
Okay, if the 4 was inside the brackets, would
We wouldn't be able to do it. Well, if the 4 was inside the brackets, like this, I would reduce. You get 11 pi over 3, and that's part of my pi over 3 family, so I know it's equal to a half. I know this is in quadrant 4, so it's positive a half. But it's outside of the brackets. The 4 is inside. Yeah. Then you have to multiply them together and simplify. So that 4 is inside. You have to do 4 times x first.
Yeah.
Just like I did when I put the 4 inside, I simplified the fraction.